Hello bachcho, good afternoon. How are you all doing? I hope all of you can see me and hear me. I am Vipul Arora, your master teacher of physics. So today we are going to start with our Newton laws of motion and friction. That next session today. Yesterday we had one session, so today we are going to take one more. Good afternoon. How are you all doing? Okay. So we are going to start with Newton laws of motion and friction. Okay, so friction is also be taken up in this session. Okay, so today what we are going to continue with, as we have done some questions and some concepts of Newton laws of motion in the last class, we are going to continue with some more questions in today's class. So let me start with some questions here. So I'll just take an example. So we studied about making the free body diagram, what we have done in the last class, how to make the free body diagram. Net force is equal to 0 for equilibrium concept, net force equal to mass into acceleration for when the body is undergoing acceleration, when there is a string in a lift and the lift is moving up, and all those things we have done up to now in the chapter of Newton laws of motion. So let us take some more questions to understand the concept of Newton laws of motion a little more better. So let's take this example. Let's say this is 20 Newton force, this is 3 kg, and this is 2 kg. Now the question is, we have to find the acceleration of this 2 kg and 3 kg blocks, and we also have to find the tension between the 2 kg and 3 kg block. So this question is pretty simple. Why? Because we know that we can feel that when this force is applied on 3 kg, this 2 kg is also coming along with the 3 kg block. So that means they both have the same acceleration. So we can actually do a concept of that we can apply the free body diagram or make the free body diagram of the whole system, and we can write 20 is equal to 2 plus 3 into A. Why I did not take tension into account? Can you tell me? Why did I not take tension into account? Because in this case the tension becomes an internal force because we are taking the whole system as one system. Okay. So from here you get A is equal to 20 upon 5, that is 4 meter per second square. Now tell me, if I want to find the tension between this 4 kg block or 3 kg block and 2 kg block, can I make that or can I get that tension just by making the free body diagram of the whole system? Give me the answer in the chat box. Can you give me the answer in the chat box quickly? Let me see. So come on quickly. Okay, so you cannot find the tension until and unless you make the free body diagram in which this tension should be drawn. So let me make this 2 kg free body diagram separately. And the acceleration is A is equal to 4 meter per second square. So you can clearly see that net force in the horizontal direction is equal to mass into acceleration, which is 2 into 4, that is 8 Newton. So you get the tension very simply as 8 Newton. Okay. So I am just taking a few examples so that you get the understanding of how to approach questions in the examination. Okay. Now let's take a step ahead. Now let me take a question in which the blocks are on the inclined plane. See, similar question which was there, which we did in the last class also, in this when the two blocks are there on the horizontal surface and we are pushing that two block system from one side. So in that scenario we said net force equal to mass into acceleration. We found the acceleration, then we made the free body diagram separately to get the normal reaction. Similar kind of thing is there now in this question, but now it is on the inclined plane. Now, how to analyze the question when there is an inclined plane and on that the block is placed? Here you have to understand that we have to take the component of the forces along the inclined plane. That component is important, and that's why that theta is important. So let me first tell that to you before doing this question. Okay, see. Let's say you have this inclined plane. Yesterday we made the FBD also for the block, and this is a block of mass m. So now what I am saying is directly, if this angle is theta, now you can also remember this, that the force along the inclined plane, this is the force due to the gravity, mg sin theta, that component along the inclined plane, and this is mg cos theta. This is normal reaction, and since the surface is smooth, there is no friction on the inclined plane. We'll assume that there is no friction. So without friction, this is the situation. Now we can clearly see that in this direction there is no acceleration. So we can say n minus mg cos theta is equal to 0. And along this, it is going along the incline downward. So you get mg sin theta is equal to mass into acceleration. So you get the value of A as g sin theta. So the acceleration comes out to be g sin theta. So one thing you can also take home, that if a block is kept on a smooth inclined plane of angle theta with the horizontal, then this block, once released, it will go down with acceleration g sin theta. But the important point is it must be a smooth inclined plane on which you have kept the block. Okay. Now let's take a step ahead. Now let us try to do this question. See, the question they are asking is, they have given two masses on smooth inclined plane, and the inclination angle of this is 30 degrees. So this is theta, they have given as 30. Question is, we want to find the force required, this F, to move the blocks up the incline. Please remember, now we have to move them up the incline with an acceleration of 2 meters per second square. A is equal to 2 meters per second square. Now, would you try this question quickly? Would you try this question quickly, bachcho? Okay, jaldi, come on quickly. Hello, beta. Hello, ma'am. Come on, come on. Quickly answer, bachcho. बेटा चैडलर, टेल मी व्हाट इज द प्रॉब्लम यू आर फीलिंग. बेटा चैट बॉक्स में बताओ मुझे क्या नहीं बात समझ में आ रही है बच्चों. जब तक आप बताओगे नहीं, मुझे कैसे पता चलेगा आपको क्या नहीं समझ में आया बच्चे. ओके, क्या पता बेटा कौन से क्वेश्चन की बात कर रहे हो. इस पहले एक बार ये वाला क्वेश्चन ट्राई तो करो. पिछला वाला क्वेश्चन जी साइन थीटा कैसे आया. पहले तुम ये वाला एक क्वेश्चन ट्राई करो बेटा चैडलर, और उसमें तुम देखना, मैं जब ये क्वेश्चन बताऊंगा तो इस क्वेश्चन से जो पिछला क्वेश्चन है वो तुम्हें ऐसे लगेगा वो तो बहुत आसान था. जो मेन लर्निंग है इस पूरे कॉन्सेप्ट की वो ये है कि जो फोर्स ऑफ ग्रेविटी जो लगेगी mg, उसका जो कंपोनेंट इंक्लाइन प्लेन में डाउन द इंक्लाइन पे होगा. सो आई थिंक दिस इज अ इंग्लिश चैनल, सो आई शुड बी यूजिंग इंग्लिश. सो the force of gravity which is in the vertical direction and the component of that force of gravity along the inclined plane, that is mg sin theta, and the component which is perpendicular to the inclined plane, that is mg cos theta. So once we have done the components of the force of gravity, then we can ignore that vertical force. Instead, we have done the two perpendicular components. Okay, Chandler? You understand now? So, let us try to do this question. Now see, you can see there is a 4 kg block. So, the vertical force will be 4g. And in this 2 kg block, it is 2 times g. But the point is, the acceleration is only along this. So first what we have to do? First we have to make the free body diagrams and we have to make the component of the forces. So in this question, what component I will choose? So I will say for this 4g, I'll write this component will be 4g sine theta. And this component will be 2g sine theta. So these are the sine theta components. For the completeness sake, I am making the other diagram also. So this will be 4g cos theta and this will be 2g cos theta. And obviously, since there is a contact force, then I need to put the normal also. So I'll just put it here. Let's say N1, N2. So for the completeness, I have made the free body diagram of this particular situation. Now the important point is, why do we do this components, that yellow and green color components? Because we know that the acceleration of the two blocks is along the direction of inclined plane up the incline. So all the forces components along the inclined plane has to be done. So now what I am trying to say, that net force in up the inclined direction is equal to mass into acceleration in up the inclined direction. So what I am doing? I am writing F minus 4g sine theta minus 2g sine theta. So this is the net force in the direction up the incline, is equal to mass will be 4 plus 2 into acceleration. So you get now F is equal to 4g sine 30 plus 2g sine 30 plus 6 into 2. Now I think you can easily solve this to get the answer. If you want, let me solve it for you. So it will be 6 times 10 into 1 by 2 plus 12. So 2 5s are 10. Okay. So you get 30 plus 12, that is 42. So beta, I am getting the answer as 42. बताओ क्या आप लोगों को, are you able to understand this point beta? Are you able to understand that the answer came out to 42? Let us check also. So yes, we got the answer as 42. Is this clear bachon? Is this clear everyone? Very good Sanyam. Okay. So the point which I am making is, the questions are not difficult. Only thing is, you have to make the free body diagram correctly and then try to get the answer to those questions. Okay. Let's take a step ahead. Let us take a step ahead. Okay. Now see, in this question, it's a pretty simple question, pretty standard question. Now the point is, they want find the tension in the string. Now if you see, from the feeling, we are able to gauge that this 5 kg and this 5 kg, since both are of same mass, this will stay in equilibrium. Okay, so simply just by looking at the question, we were able to understand that if this is 5 and this is also 5 kg, so this is 5g, this is 5g, and since from the feeling we are able to understand that there is no acceleration of these blocks in either direction, so we can say the acceleration is 0, either up or down, 0 anyways, no problem. Or I can say t minus 5g is equal to 0. So you got the value of t as 5g, that is 50 Newton. So question is done, the answer you got. Now please remember that you have to get the tension after making the free body diagram and drawing the acceleration direction also. Okay, let me tell you one more question in this regard. If these two are not equal, then can you try this question? See, they have given M1 as 5 kg and M2 as 10 kg. Now the question is, when you release these, what is the acceleration? So can you tell me one thing? What do you think? Will they be in equilibrium? Can you tell me in the chat box? Will they be in equilibrium? Can you tell me in the chat box, bachon? Will they be in equilibrium? Quickly tell me. Answer is no, they are not in equilibrium, because this 5 kg is less than 10 kg. So they are going to go down with acceleration A. This M1 is going to go up with acceleration A. Why it is going up? Because it's a string, and truly speaking, this string constraint is what is being applied here in this question. Although since it's a simple constraint, we can feel that how much displacement this block goes down, the other block goes up. So with whatever velocity the block goes down, the other block goes up with the same velocity. With whatever acceleration this block goes down, the other block will go with the same acceleration magnitude in the upward direction. Now, how to get this answer of acceleration? Now, see, there are two ways in this. I'll tell you both the ways because you should understand the concept as well as the trick to solve the question. See, first conceptual point is that you have to know how to draw the free body diagram. So, let me say this is M2G, this is tension T. In this also the tension is T, this is M1G. Please remember the tension in the same massless wire remains same. Now, I will make the free body diagram of this. So now we know, we have assumed the acceleration of this in downward direction. So I can write M2G minus T is equal to M2A. For this, if you see, T minus M1G is equal to M1A. So net force in the downward direction is equal to mass into acceleration for M2, and for M1 net force in the upward direction is equal to mass into acceleration of M1. Now we are saying that we have two unknowns A and T. We can solve. If you want, I can solve, but I'll just give you the answer also. You get the answer as M2 minus M1 into G upon M1 plus M2. See, in this question, it is also important to remember the answers directly because that will save time in the examination. So you get the answer of tension and the acceleration in this question. This will surely be of help, okay? But the point is, in this question, what we did, we made the FBDs, then we wrote two equations for each, one equation for each block, net force equal to mass into acceleration, and then solved two equations to get the answer. That's what we did in this question. That's the standard way of doing this question. But now I will try to do this question again, but now I will do it with a trick, and that trick is also going to help you in various places. So let me show you the trick. See, let's say you have this F2, M2, M1, F1, and somebody wants what is the acceleration of these blocks. So what we say, in our mind we try to think like this, and we say F2 is pulling in this direction, minus F1 is preventing that pulling. That is equal to M1 plus M2 into A. So you got the A as net supporting force minus net opposing force upon the mass of who all are moving. See, F2 is the net supporting force in that motion. F1 is the net opposing force, and mass M1 plus M2 because M1 and M2 are moving. So you got the acceleration in very quick manner. Now, if instead of this question you have this question, can you try to give me the answer? Can you tell me the answer in the chat box? Quickly tell me the answer in the chat box. Come on. Come on, tell me the answer in the chat box, bacho. See, it is simple. Supporting force minus opposing force upon the masses of who all are moving. Can you see M1 is moving, M2 is moving, and M3 is also moving? This is important, beta. This is important. M1, M2, M3. So sum of all the masses which are moving. Okay. Now, this looks pretty simple. But the same trick I am going to use for this question as well. See. So this is, let's say, M2. So it will try to move this whole thing in this direction. This is M1. Now, if you see what we are trying to do, we are trying to, use the similar kind of concept to apply the Newton law for a system along the whole string. So in this case, since the string is very, it's just a straight string, there is no confusion. But in this, you have to pay a little attention to things. Can I say this M2G is the supporting force? It tries to pull M2 down, and same thing tries to pull M1 up because of the string. Now, this M1G is trying to oppose. This M1G is trying to oppose this movement of M1 upward and M2 downward. Now, because of this opposition, I will say the acceleration of this M2 and M1, that magnitudes are same and the direction is different. A is supporting force is M2G, but this M1G is the opposing force. Please remember, M1G is the opposing force. M2G is the supporting force, M1G is the opposing force upon the mass of all those who are moving. M1G is the opposing force, M2G is the supporting force. Okay. So this is why this question is an important concept which you have to take home. Okay. Now, can you see one more example? Let's see. So let's say M2, M1, M3. Now M2G tries to move the system like this. M1G tries to oppose this whole system movement. So I want to know the acceleration. So let me assume the acceleration A. Now can you give me the answer of acceleration very quickly in this? Again, the concept is supporting force minus net opposing force upon the masses of who all are moving. Now the interesting point is, do not forget that M3 is also moving. M1 plus M2 plus M3 is what you need to take, because M3 is also moving, M1 is also moving, and M2 is also moving. Tell me, is this point clear to all of you? That in this case, the supporting force is M2G, opposing force is M1G, but in the denominator, the masses of all the three needs to be counted, because they all three are moving along the string. Tell me, is this point clear to everyone? Tell me in the chat box, bacho. Very good, beta. Sambari, Sanyam, Chadler, Batri, very good. Kiran, Abdul. Okay, so very good question, Sanyam. Sanyam is asking, sir, M3 is not opposing motion. Now please remember, if you see M3G is in downward direction and there is no component of M3G along the string. The normal is also like this. There is no component of M3G or normal reaction along the string. So what you have to do, you have to take all the forces along the string. I will take one more example in which what I will do, I'll put a force here. And if I put a force here, you will see that then this force will come in that expression. Okay, we'll talk about that. I take example, just a second. But before that, I want to ask you whether you can do this question or not. Can you answer this question for me, bachcho? Quickly. So options are A 1 and 2 meter per second square. So can you answer it in the chat box quickly? Okay, just tell me in the chat box you are trying, if you are trying the question. Come on. Okay, very good, Sanyam. Patri, Ashwita, very good. Come on. Chaglar, where have you gone? Kiran, Sambari, very good. See, in this question, it's a similar question as we have just done in the previous slide. So if you see, this is 1G, this is 3G. Obviously 3G is greater. So this is acceleration A. Now I am saying supporting force minus opposing force upon whole mass which is moving. This is equal to A. So what is the acceleration A? 2G upon 10, which is G by 5, which is 2 meter per second square, which is this answer. Understood, bacho? Is this clear to everyone? Now let's take a step ahead. Okay. Now let me tell you quickly about the concept of weighing machine and the spring balance. Okay. See, one thing you should know, when you see a weighing machine and there is a reading like this here and there is a needle. Okay. So please remember, the reading of the weighing machine is the force that is acting on the, so this normal is what will be given as a reading. Either they give this normal reaction in newtons, or they give this normal reaction value and divide by 10 to get the answer in terms of kilograms. Please remember that. So either they give reading in newtons or in kilograms. If they give reading in kilogram, meaning that value multiplied by G or maybe 10, that will give you the normal reaction on the top of the or top surface of the weighing machine. That is the concept of weighing machine. Now, what is the concept of spring balance? I'll write it here only. Spring balance. So you may have seen this at your home sometime. Like this. So what happens? Like, so there is a slider here. Now, when you hang something here, then the slider comes down to this. And this is what they give you the reading. So what the reading of spring balance gives you? Now to take home point, reading of spring balance gives you the tension in the spring. Is tension in spring or the spring force. Tension in spring of the balance or spring balance. So tension in the spring of the spring balance. Okay. Now, one thing you must be able to understand, that what has actually happened, because of this weight, the spring has expanded, and as a result of which there is a shift in this arrow, and that arrow is showing you the reading of the spring balance. So can you see that spring balance reading is the tension in the spring? They can give you in newtons or in kilograms. That is just either in kilograms, so you multiply by G to get the answer of reading of the spring balance or the tension in the spring balance. Okay. So these two concepts should be understood because questions are similar to what we have done. So for example, if I say this is a weighing machine, this is 8 kg. Now this is in a lift and this acceleration is 2 meter per second square. So the question is, what is the reading of the weighing machine? Question is, what is the reading of the weighing machine? Can you tell me in the chat box quickly? Can you tell me in the chat box quickly, bachcho? Come on, come on. I am waiting. Can you tell me in the chat box very quickly? Okay. Bathri, Sambari, Ashwita, Sanyam, Chagler, Kiran, Abdul, come on. Okay, very good. Sanyam has given some answer. But beta, think, this particular lift is going in the upward direction with an acceleration. And when there is an acceleration and you have to solve the whole question to find the normal reaction. Do you understand, Sanyam? Yes. See, Sanyam got the correct answer. See, point is you have to make the free body diagram of 8 kg block. Why are you making the free body diagram? Because you want to find this normal reaction, because this normal reaction is same as the normal reaction which is acting on the top surface of the weighing machine. Okay. Now, this acceleration is 2 meter per second square. Now I am writing net force in the upward direction is equal to mass into acceleration. N minus 8g is equal to 8 into acceleration. N is equal to 8g plus 8a. 80 plus 16, that is 96 newtons. So what you can do, you can give the answer in terms of newtons for the weighing machine reading, or you can say the answer or the reading of this weighing machine is, in this example, 9.6 kilogram. You just divide this 96 Newton by 10 to get the answer in kilogram. Is this clear to everyone? Because I am going to make a small change in this question and then I ask you the similar kind of question. So then you have to answer me correctly in the chat box. Okay, beta, Sambari? Understood, bachcho? Tell me quickly in the chat box. Come on. Okay, so similar question. The only difference now is this is going down with an acceleration of 2 meter per second square. Give me the answer of reading of the weighing machine in kilograms. I want an answer in kilograms. Quickly tell me. Waiting for you. I'll wait complete 30 seconds for you. Come on, come on. Okay, Sanyam, Batri, very good. What about others? Somebody? What about others? Come on, देखो, try to see बच्चों. You make the free body diagram. Now, since the acceleration is downward, I am assuming net force in the downward direction should be equal to mass into acceleration in the downward direction. So, 8g minus n is equal to 8a. N is equal to 8g minus 8a. 8 into g is 10, a is 2. That is 64 Newton. But since you want the answer in terms of kilogram, the reading of weighing machine will be 6.4 kilogram. So did you all understand, bachon, that depending upon what is the normal reaction acting on the upper surface of the weighing machine, you will get the answer accordingly. Okay. Now let's take a step ahead, bachon. So that's what we have done. Now this is an interesting question, slightly with a different thought process. Now here I also want to introduce a some point or some thought about concept of pseudo force. But before that pseudo force concept, I will also tell you that I could have solved this question without the knowledge of pseudo force. So first I am going to not use any pseudo force and solve this question. Let us see what is this question all about. There is a car which is going towards right with an acceleration of a. Okay. Now the question is, we want to find what is the angle theta such that this, or which is made by the string with the vertical. That is the question. Now just to make you imagine, you may have seen when there is a truck and a truck goes with some acceleration, the flap, the mud flap or the flap in the back of the truck, it goes like this. So if the truck is going like this, the flap goes like this. And then when the truck stops, it comes back. Or I would say when the truck puts brake, it goes like this. So maybe you have observed that. Maybe you can now observe. Okay. But the important point is that this is the situation which we have to find that angle theta. Okay. Now how to solve that? So very simple. I am observing from the ground frame only and I am saying this is mg and this is tension T and this angle is theta. Now can you see in the frame of ground when you are observing this ball is going towards right with an acceleration a. Why? Because it is connected to the car and this car is going with a. So this ball is also going with a. That is the most important point. Now, as soon as we get it, can I say T cos theta minus mg is equal to 0. Why? Because there is no vertical acceleration of the ball. Ball is only going towards right with acceleration a. And T sin theta, which is this component. See, T cos theta is this component, and that's why I am saying this component is important. T sin theta is equal to mass into acceleration. Now you can see if you take this on the right side and then divide, you get tan theta is equal to A upon G. So theta will be equal to tan inverse of A upon G. This is your answer. Understood, bacho? Is this clear to everyone? Very good, beta Sanyam, very good. Okay. Now this question I want to do one more time, because through this I want to introduce, just to tell you, a concept of pseudo force as well. See, in this question I have made the free body diagram sitting on the ground and seeing that this ball is going towards right with an acceleration A. That's what we have drawn. That's how we have drawn the free body diagram and then solve the question accordingly. That's why we wrote net force is equal to mass into acceleration. Now I am going to do this question one more time, but now with the help of a concept called pseudo force. and it will only be applied when the FBD is made in an accelerated frame of reference. Please do remember that. Meaning, if the observer, accelerated frame of reference or accelerated frame of observer, means if the observer also has some acceleration, only then you will apply the pseudo force in that FBD and then solve it accordingly. Further, the pseudo force magnitude is given by mass into acceleration. Mass, whose mass? Mass of the body whose FBD is made in accelerated frame of reference. And now, can you tell me this acceleration is what? Is this acceleration for the body or is this acceleration for the frame of reference? Tell me in the chat box. What do you think? Is this acceleration of the body or is this acceleration of the frame of reference? Come on, quickly. Come on, come on. Satvik, my question is this acceleration of the body or is this acceleration of the frame of our reference? So this acceleration of the to find the magnitude of pseudo force, this acceleration is acceleration of frame of observer or the frame of reference. Who is making the FBD? But what is the direction of that? What is the direction? The direction of pseudo force is opposite to direction of acceleration of frame of reference. So please remember in this, the acceleration which you have to take in the magnitude also, that is that of the frame of reference, and the direction is opposite to the direction of acceleration of frame of reference. Let me tell you what do I mean. So let us do the same question again. Okay. So I'll make the FBD mg tension T. So that is all okay so far. Now I am going to make this free body diagram. Let's say I am going in the car and here I am going to make the free body diagram of this particular mass. So can I say the acceleration of this person is same as that of the car in this question? If the acceleration of this person is same as that of the car, so the direction of pseudo force acting on this M will be opposite to the acceleration of this frame of observer. So the direction of pseudo force will be this direction. And what is the magnitude of pseudo force? Mass of the body whose FBD is being made into magnitude of acceleration of frame of reference. So for this person, the acceleration is the A. So that's why M of this body and A is the acceleration of the frame of reference. See, in this question, please be very clear that this person's acceleration is same as that of the car. This question could have been done in another car which is having some acceleration B. Then you have to put the things accordingly. Okay. Now the interesting point is, can I say in the frame of this person, this ball is actually stationary? Imagine this ball has no movement or no acceleration if you are sitting on the car. Can you imagine that, bachcho? Now the question is pretty simple. I'll just do the components. So this is t sine theta and this is t cos theta. And since it is in equilibrium, I'll write t sine theta minus ma is equal to 0. T cos theta minus mg is equal to 0. So now solving these two, you can divide to get tan theta is equal to a upon g, and theta therefore is equal to tan inverse a upon g. Direct question without any problems. Okay, bachcho, is this clear? Quickly tell me. No, beta Sanyam, it is not the back of actual acceleration, opposite to actual acceleration. It is opposite to the acceleration of frame of reference. Please remember very, very clearly, Sanyam, it is not the acceleration of, or it is not opposite to, or we are not saying that it is opposite to acceleration of the body. It is opposite to the acceleration of the frame of reference. Please keep this in mind. This can be asked in the assertion reason question as well. Okay, so be clear about it. Now let us take step ahead and let us try to do some problems. So there are more problems of this concept. Let me take some problems of the friction. Okay. Okay. Now for friction, I will say now I can introduce friction in the questions by saying, see, friction are of two types. We will be using static and kinetic. That is what is relevant for us. So we are talking about two kinds of friction, static friction and kinetic friction. Just to develop the feeling, see, you may have tried to push the bed from some location to other location, or maybe some almirah or that cupboard you may have tried to push. Now the problem is, when you try to push, in the beginning it is very difficult to start the slipping of the let's say sofa or bed or anything heavy. But once that slipping starts, it is easy to maintain that slipping. So generally, whenever there is a relative slipping that has already started, it is happening. In that situation, the friction that is opposing the slipping is called as kinetic friction. But the static friction is developing when there is not an actual relative slipping happening. So it is not happening in that situation when you try to start the slipping of the bed or the sofa or the almirah. Okay. But there is a tendency to slip. So for example, if I say, let's say this is one surface, this is another surface, and I am trying to push this surface on the bottom surface. Now you see, the slipping is not there. The slipping is not yet started on the bottom surface here. But there is a tendency. I hope you can feel that I am trying to push it towards right, but the slipping has not yet started. So in that situation, the friction is static friction. See, the important point is, when we talk about static and kinetic, you can see that out of the two, only one may be acting in a situation. But you have to be very clear, when the slipping started, then the friction has become kinetic, if it is there. And when the slipping is not yet started, but there is a tendency to slip, then the friction is static. Now, just to give you a revision of this thing. So if the friction is kinetic, we say this value is mu k into normal reaction, where normal reaction is the normal component of the contact force at the contact surfaces. So when there are two contact surfaces, so the normal force between the two, that normal. So this normal comes here, and friction is the tangential component of the contact surface, which is acting on the tangential direction. I will be showing you some diagrams also, but just to give you the magnitude. So when kinetic friction is there, you use mu k into n. This mu k is called the coefficient of kinetic friction. Coefficient of kinetic friction. For static friction, the concept is this value of static friction develops according to the need. What is the need? The need is to make sure that the slipping should not start. So the value of static friction arises according to the need. I will show examples to make sure you understand. But just for the completeness sake, the important point is that the value of static friction goes from 0 to a value called Fs max, which is also called as limiting friction or limiting value of this friction. Limiting value. Limiting value of friction. Fraction. Limiting value of friction. Okay. And this, so I'll just write it in other words. This is given by mu s into normal reaction. So please remember, static friction arises according to the need, and there is a range of values of static friction from 0 to mu s into n. But if the kinetic friction is there, that is a single value, which is mu k into n. Mu s is the coefficient of static friction. Now, in general, the value of mu s is greater than the value of mu k. Because in general, the value of mu s is greater than the value of mu k. But if they have not mentioned separately in the question about mu s and mu k, and they want both of them, and they have only given one mu, so we can use both of them as same. But that depends upon the question. In general, this is the case. So you can see that when you start to move that heavy thing, it was difficult for you to overcome the static friction. But once you have started and the friction has become now kinetic, it is easier for you to maintain that motion. I hope you got this feeling. Tell me in the chat box. Bacho, did you get this? Okay. Now, so this is the basic understanding of concept of friction. Now, how to think about it? So let us show you things here. Let's say this is the block, and let's say this is 8 kg. Let's say I give the value mu s as 0.6 and mu k as 0.5. Now, can I say in this question 8 is there, n is there, n is 8g, which is 80. Now, this block is like this stationary. Can you see in this situation there is no friction at all? Why there is no friction? Because first of all, there is no slipping between the block and the ground surface. First of all, there is no slipping. Second, even though there is no slipping as well, there is not even a tendency to slip. So there is no static friction as well. So you can say static friction is also 0. So static friction is also not there, and kinetic friction is also not there because there is no slipping at all along the surface. Okay. But let us say now I give this it has some velocity. V is equal to some 10 meter per second, just to say. Now, can you see there is a slipping in this direction? So the kinetic friction will start to act on this in the backward direction because it opposes the slipping. It has to oppose the slipping. So the kinetic friction in this question will start to act on the block in this direction, and that will be Fk. And the value of Fk in this question will be mu k into mg. Why? Because let's say m is equal to 8. So because n is equal to m times g. So mu k into normal reaction in this question will give you Fk. Because of Fk, there will be a retardation or I would say acceleration in the backward direction, which is Fk upon m, which is mu k into g. So you can see very clearly that the block is going to retard, and what will happen finally? This block is going to slow down, slow down, slow down, slow down, and finally becomes zero, or finally comes to rest on this ground. Can you see, in that process friction will be kinetic and being put in the opposite direction as of the velocity, or I would say the slipping. What will happen after that? What will happen after that instant when it stops here momentarily? In this question it will just stay there, because there is no tendency of that block to slip anywhere, and then friction will stop acting after that instant. Okay, that's the feeling. But please remember one thing, in this question, why did we say kinetic? Friction is kinetic. Why we did not say friction is static? Because this block has a velocity and there is a slipping happening between the bottom surface and the block surface. Okay, this is important, that why the friction is kinetic in this question and not static. Now let me ask one more thought here. If you have this block, let's say 8 kg only, mu s is 0.6 only, mu k is 0.5. Can you see, again this is 8g, this is n is equal to 8g, that is 8t. Now the question is, if I am applying a force here, so this is not slipping, I am just applying a force F0. I am just applying a force F0. The question is, if I apply a small force F0, will this block move? Tell me. Answer is no. So let us say, I'll just say this thing F0 and whether block start to accelerate, yes or no, and find A. Now see, let's say I am applying 3 Newton. So you can see that the friction will start to apply in this direction, and the value of friction will be 3 only. Now, and this will be a static friction. Why it will be a static friction? Because the block has a tendency to move towards right with the 3 Newton force, but static friction can develop that value. And as a result of which the block is not going to move, because static friction has arisen to prevent this block from slipping. Let us say I make 6 Newton, static friction develops 6 Newton, here also A is 0, here also A is 0. Now the point is, will this go forever? No, wait. You have to check the limiting friction. If you see Fs max, by definition mu s into normal reaction, that is 0.6 into 8g, which is 48 Newton. Meaning till that value of 48 Newton, this block is not going to slip on this particular ground. So I say if it is 47, Fs is 47, acceleration is still 0. But when it is 48, then what do you guys say? When it is 48, then static friction is 48, acceleration is still 0. But there is something special about this. In this particular example, there is something special about this. Can anyone tell what is something special in this? Tell me what is something special. Something special is that friction has reached its Fs max. That is the limiting value. And there it is saying, I cannot increase more than this particular value in this particular example. So, if even a slightest of force acting on this block in the right hand side direction, even the slightest of force acting on this in this direction, let's say I'll say 48.0001, just a very small force, then it says that friction has become Fk, whose value will be mu k into normal, and Fk will be 0.5 into 8g, which is 40. So you can see when it was 48, it was on the verge of slipping. As soon as it is even slightest greater than that 48 Newton, the friction has become kinetic, because the slipping has started. As soon as the slipping started, the friction has become the kinetic friction, and as soon as it has become kinetic friction, now you can see acceleration will be equal to 48.0001 minus 40 upon what is the mass? 8. So it will be nearly equal to 1 meter per second square. So you see, when it was 48, the acceleration was 0. As soon as it increased with the slightest of more force, the acceleration has become 1 meter per second square. And so on, it can move ahead and so on value. So this is called the critical value, which is called as the limiting friction scenario, and we call this situation as the verge of slipping. So this situation is something which is very crucial, and we call this situation as verge of slipping. Okay. So I hope bachon you understood things. We call this verge of relative slipping basically. Okay. Chalo bachon. So let us stop for now, and please try to solve the questions. We will be sharing all the notes in the description box. Do download them and solve more questions in the notes. Further, you should also let me know in the comments after the class gets completed. You can let me know in the comments where you or what concepts you want to read more, study more from me. I will try to bring that in the further lectures. Okay. And you can also reach out to me if you guys want. My Telegram ID is @Vipul Arora Physics. Okay. You can reach out to me @Vipul Arora Physics for any thoughts or any doubts you have. Let me know. Okay. Chalo bachon. So keep learning, keep enjoying. Bye bye. Take care, everyone. Bye bye. See you. Bye bachon.